Hi guys, welcome back to my YouTube channel. So in this video, we're going to discuss another set of topic in mathematics, specifically in differential calculus. So we have to show or to solve in this problem, or in this video, that the difference of using implicit differentiation and explicit differentiation in solving or in getting the derivative of a certain equation. So we will use the same equation in this video to assess if we will arrive at the same answer using the two way of finding the differentiation of an equation or the derivative of an equation. So let us proceed with implicit differentiation. So our equation to be used is we have the equation defined by x cubed plus y cubed minus 6xy is equals to 0. So with this, in implicit differentiation, you are just going to directly get the derivative of each term consist in the given equation. So we are going to get the derivative of each term. So you have x cubed, derivative of x cubed, or the entire equation. Afterwards, after getting the or expressing this one in terms of getting the derivative of the equation, just simply distribute the denotation or the notation for derivative into each term of the equation. So distribute the notation for the derivative, d over dx of x cubed plus d over dx of y cubed minus, in this case we have numerical coefficient. So we have to write first the numerical coefficient before the notation for derivative. So notice that we have numerical coefficient here. So dx of xy is equals to 0. So then afterwards, simplify this one or get the derivative of each term. So derivative of x cubed or d over dx of x cubed, that will be applying the concept of power rule. So you have to get 3x squared plus derivative of d over dx of y cubed. Since you cannot, this is not an x variable, so it will become 3y squared y prime. So derivative of y cubed will become 3y squared y prime. So since y prime is equals to dy over dx minus 6 times derivative in here, we can use product rule in here, or you can have to avoid long process. So we have to express this one in terms of the derivative of xy in terms of x, you will get y. Then we all know that in product rule we have to add the derivative of the two expression or equation, variable here. So derivative of x y in terms of x, that is only y. Then plus derivative of x y in terms of y, you will get x y prime is equals to 0. So again, you can check this one by using product rule, or simply express that one in terms of derivative of xy in terms of x, you will get y. Derivative of xy in terms of y, you will get xy prime. Then add the two result. Then simplifying this one further, so we have combined terms with the same, or we have to simplify this one further. We have to distribute negative 6 in this side. So we have 3x squared, copy 3y squared minus 6 times y, 6y, negative 6 times xy prime, that will become negative 6xy prime is equals to 0. Then afterwards, combine term or combine expression with the same terms. So as you notice here, we have y prime common to these two expression, negative 6y minus 6xy prime, or this 3y squared y prime and negative 6xy prime. So we have to transfer 3x squared and negative 6y to the other side. So we have, or let us combine like terms, 3y squared minus, 3y squared y prime minus 6xy prime is equals to 3x squared, my negative 3x squared plus 6y, because 3x squared transferred to the other side, it will become negative 3x squared. Then negative 6y transferred to the other side, it will become positive 6y. Now, since in the left side, as you notice here, notice that there is common between these two expression, 3y squared y prime and 6xy prime. So what we're going to do is to factor out common term, which is y prime. So by factoring, or if we factor out y prime in these expressions in the left side, you will get 3y squared minus 6x is equals to negative 3x squared plus 6y. Then afterwards, since we already get the y prime, or that is equivalent to dy over dx, or the notation for derivative, so we already know that dy over dx is equals to y prime. So we can get that y prime, divide both sides by this expression, so you will get 3y squared minus 6x is equals to negative 3x squared. So let me copy it again. So to make the left side as y prime only, or to get the derivative of the expression, so just simply divide both sides by 3y squared minus 6x. Then also the left side with 3y squared minus 6x. Our purpose here is to make the left side as y prime only, or to express this one in terms of the derivative of the function or the equation. So cancelled out this one, and you will get y prime is equals to negative 3x squared plus 6y can also be expressed in terms of 3 times negative x squared plus 2y. So we simply factor out 3, and then here we can also factor out 3 y squared minus 2x. So therefore, the answer will be, or the derivative or the differentiation of the equation will be negative x squared plus 2y all over y squared minus 2x. So where did we get this one? Since we can cancel out 3, so the remaining expression in the numerator will be negative x squared plus 2y, and in the denominator will be y squared minus 2x. So this is the result using the implicit differentiation. So this is already the answer for, or the derivative of the expression or the equation given, which is x cubed plus y cubed minus 6xy is equals to 0. Now let us use explicit differentiation to assess if we will arrive with the same answer, which is this one. So let us have the same example, or the same equation to be used. We have the equation defined by x cubed plus y cubed minus 6xy is equals to 0. So in this case, the first thing that we're going to do here is to express the equation in terms of y. So you are going to express this one in terms of y. So you will get y cubed is equals to, transfer all terms in the right side, so it will become negative x cubed minus y cubed. I'm sorry for this, plus, sorry, we retain y cubed here, so you will get plus 6xy. So again, this is not included. So we have y cubed. We have to, our purpose here is to express the equation in terms of y. So we have y cubed will be retained in the left side, and other than y will be transferred to the left side or to the right side. So positive x squared transferred to the other side, it will become negative x cubed. X cubed, positive x cubed transferred to the other side, it will become negative x cubed. Then we have negative 6xy transferred to the other side, it will become positive 6xy. So we're not done yet. We have to make the left side as y only. So we have to get the cube root of both sides in order to eliminate the power or the exponent here, which is 3. So whatever you are going to do in the left side will also be applied in the right side. So getting the cube root of y cubed, then also we have to get the cube root of negative x squared, x cubed plus 6xy. So simplifying further, so cube root of y cubed, that will be y, is equals to the cube root of the expression defined by negative x cubed plus 6xy. So here we can apply the power rule, or we can rewrite this one into exponential form. So notice that the power rule is defined by the derivative of d of dx, that is square root of u, is equals to 1/2 2 square root of u, 1 over 2 square root of u times the derivative of the inner expression defined by u. So if we are going to use this rule for differentiation, we can simplify this one. So let us use this way of solving, or this rule of differentiation. So we have here now derivative. If we are going to get the derivative of this one, so you can say, we already know that dy over dx is equals to y prime. So if we're going to get dy over dx, so is equals to d over dx of the cube root of negative x cubed plus 6xy here. Then afterwards, dy over dx can also be expressed in terms of y prime is equals to, so derivative of this expression here, following this rule of differentiation, will be, since this is cube root, you will get 1 over 3. So our u here is negative x. So let us remember that our u in this expression is, okay, let me rewrite it here. So let me write it here. U will be is equal to negative x cubed plus 6xy. So this is the value of our u. So following this format or this rule for differentiation, so we can have, since this is cube root, you will get 1 over 3 square root of our, we have our, cube root of negative x cubed, since u, and our u is negative x cubed plus 6xy plus 6xy, then times or multiplied to the derivative of u. So you will get d over dx of our u is equal to, in this example, is negative x cubed plus 6xy. So let us simplify this one further. So this is 3 cube root of this expression. So we follow the power rule for differentiation, this one. So next we have y prime is equals to 1. If we are going to convert this one back to this expression, we can say that this entire cube root of negative x cubed plus 6xy is only equal to y. Okay, again, the expression defined by the cube root of negative x cubed plus 6xy in the first way of determining the value of y is equivalent to y, right? So y is equals to this expression. So we need to say, if we are going to get the value of this, it is equivalent to, if we are going to, this value is equivalent to y, since here the equation states that y is equals to the cube root of negative x cubed plus 6xy. So cube root of negative x cubed plus 6xy is equivalent to y. So that is why 3 times y, or that is 3 times y, 3y. Then times derivative of this expression. So we have derivative of negative x cubed will be, so let us distribute first the notation for derivative, plus d over dx of 6xy. So here y prime is equals to 1 over 3y. So times derivative of negative x cubed. So applying the simple rule for the power rule, so we have negative 3x squared. Derivative of negative x cubed will be negative 3x squared, plus derivative of 6xy that will be, since we have here a constant or a numerical coefficient, so you have to write that one first, then get the derivative of xy. So derivative of xy in terms of x, that will be y, then plus derivative of xy in terms of y, you will get xy prime. So simplifying further, y prime is equals to 1 over 3y times negative 3x squared. Distribute 6, so 6 times y, that is 6y. 6 times xy prime, that will be 6xy prime. So now we have to simplify this one further. So y prime is equals to 1 over 3y times this expression, you will get negative 3x squared plus 6y plus 6xy prime over 3y. Then afterwards, we have to perform cross multiplication. So we have to cross multiply in order to find the value of, or to simplify this one further. So y prime times 3y, that will be 3y y prime. Then 1 times this expression in the numerator in this side will become 3x squared plus 6y plus 6xy prime only. So notice that both sides has common between y prime. So we have to transfer positive 6xy prime to the other side. So we will get 3y y prime minus positive 6xy prime to transfer to the other side. It will become negative 6x y prime is equals to negative 3x squared plus 6y. So then, so let me rewrite it again in the other side. So we have here 3y y prime is equals, minus 6xy prime is equals to negative 3x squared plus 6y. So I just rewrite it again, or rewriting this one, because to have more space for the succeeding solution. So we have here 3y y prime minus 6xy prime is equals to negative 3x squared plus 6y. So with that, we can factor out, notice that we can factor out y prime in this side. So factoring out y prime, you will get 3y minus 6x is equals to negative 3x squared, copy 3, negative 3x squared plus 6y. Then to eliminate 3y minus 6x in this side, just simply divide that one with 3y minus 6x. So divide both sides by 3y minus 6x to make the left side as y prime only. So negative 3x squared plus 6y also will be divided with 3y minus 6x, because whatever you do in the left side will also be applied in the right side. So in this case, 3y minus 6x in the left side will be cancelled out, so the remaining expression will be y prime is equals to negative 3x squared plus 6y all over 3y squared minus 6x. So notice that numerator and denominator have common term, or you can factor out 3 both in the numerator and denominator. So we factoring out 3 in the numerator and denominator, will get negative x squared plus 2y. And so also with denominator, so we'll factor out 3, so we'll get y squared minus 2x. So simplifying further, so 3 divided by 3 cancelled out 3. We will get x squared plus 2y all over y squared minus 2x. So since we can no longer simplify this one to lowest term, so this is already the final answer. So meaning to say, this is the result after we use explicit differentiation. And notice that using implicit differentiation, we also get the same result, or the same answer, which is negative x squared plus 2y all over y squared minus 2x. And the same here, which is negative x squared plus 2y all over y squared minus 2x. Meaning to say, that explicit differentiation and implicit differentiation can be used in getting the derivative of an equation, but for explicit differentiation, you will express first the equation in terms of y, but in implicit differentiation, you are just going to directly solve for the derivative of each term in the equation. So for me, it is much easier to use implicit differentiation. Maybe it depends on the type of equation given. So again, it is more convenient to use implicit differentiation if the given equation is in this form, because explicit differentiation takes so much solution and a long process to go. So we have shown that implicit differentiation and explicit differentiation can be used in getting the derivative of an equation. So that's all for this video. I hope you learned something about the explanation I provided based on my capacity to explain the difference between getting the derivative of an equation using implicit differentiation and explicit differentiation. So thank you for watching, and don't forget to subscribe. See you to my next video. God bless everyone.